Hi guys, we are from Group 3 and today we are introducing humidification and its applications. Have you seen those large, bulky units with steam or mist coming out the top of factories? Those are cooling towers, and at their core, they work on the same principle as many humidifier, which is evaporative cooling. It starts with spraying water over a large surface area. The air will be blown across the water. The dry and hot air molecules will grab the water molecule and evaporate them. This evaporation steals heat from the remaining airflow. The result was the air getting cool and humid. And the driving force for this process was different in water concentration. The humidifier was the job of cooling tower is to reject heat from industrial process, whereas humidifier was add moisture to the air of a room. But what if we don't have cooling tower? Machines will overheat, cause production stops, and workers will suffer in heat stress and factory AC will need to fight against the excessive heat produced by the production line.
So when we are talking about separation in humidification, basically we are talking about how to separate the water vapor from the air. So here we are going to discuss the two techniques in humidification. The first one is humidification. It is an action where you add or you move the water into the ambient air, causing the water content of the air to increase. Usually, this is used in cooling or heating the air in the industry. Next one is dehumidification. It is exactly the opposite of humidification. So when you dehumid something, you are stripping the water vapor from the air into liquid. You are condensing it. So you are decreasing the water content in the air, making the air dry, and in some cases in the industry, it increases the temperature of the air slightly.
There are lots of applications of humidity in different industries. I will focus on agriculture, paper and textile, as well as pharmaceutical. In order to maximize the crop yields and create ideal conditions for plant growth, humidity level in greenhouses and agriculture must be controlled. Industrial humidification systems help to maintain the relative humidity within a range of 50% to 70%, which support photosynthesis and reduce plant stress. Proper humidity control reduces water loss through transpiration. The stability can improve productivity. Not only that, in the textile and paper industry, maintaining precise humidity level is critical for product quality and operational efficiency. Industrial humidification systems are commonly used to keep humidity at approximately 65%. This can reduce yarn breakage during processing and help to prevent fiber breakage. Regulated humidity reduces dust accumulation and static electricity. Consistent humidity levels are necessary to avoid issues such as paper curling. In pharmaceutical industry, tablet coatings with aqueous solution need precise humidity to ensure the coating does not dry too fast or too slow. A more effective production line, lower waste, and high manufacturing yields can all result from proper humidity level.
So for the next slide, 4.0 technology advancement. Traditionally, humidification relies on three systems: immersed electrode, electric heater, and gas-fired systems. These methods use joule heating or direct heating, require treated water, and consume a large amount of energy. However, modern technology introduces the adiabatic humidifier. It works through natural evaporation using heat from the air instead of an external heater. Water is sprayed as ultrafine 10 micron droplets which evaporate instantly and produce cool, humid air. Most importantly, it uses only 4 watts per kilogram compared to 750 watts in steam humidifiers, saving over 90% energy. This makes it highly efficient, hygienic, and suitable even for hospitals. So, moving on this other slide, we will look other advanced humidification technologies. First, ultrasonic humidifiers use high frequency vibrations to break water into fine cool mist through cavitation. They are very energy efficient and also provide a slight cooling effect, making them suitable for indoor environments. Next, centrifugal humidifiers work by spinning a disk to atomize water, which is then distributed by fans. These systems often include auto-cleaning cycles, helping to prevent water stagnation and maintain hygiene. Lastly, compressed air atomizers combine air and water to produce very fine droplets with added UV sanitation and filtration. They will deliver a very high purity and hygienic humidification, ideal for sensitive or industrial applications. So for this part, the technologies offer strong engineering and performance advantages. It uses up to 90% less energy compared to traditional steam humidifiers. Advanced aerospace-grade ceramic insulation reduces condensation losses by another 90%, which is further improving efficiency. From a hygiene perspective, batteristic materials and automatic cleaning systems helps to prevent microbial growth. Smart control features such as real-time humidity sensing, DMS compatibility, and automatic drain and refill ensure stable and reliable operation. These systems are highly relevant in industries such as HVAC and air handling. Separation processes using desiccant and dehumidification, gas processing, clean rooms, and manufacturing sectors, including food, pharmaceutical, and textiles.
So for this section, I will explain about optimization and challenge in humidification system. So the main objective is to balance reliability, safety, cost efficiency, and smooth daily operation. So first is technology selection. Ultrasonic a humidifier provide very accurate humidity control with filter or not heat, making them suitable for sensitive environments. So automatic system offer high humidification capacity with lower energy use, making them ideal for large-scale operation. So next is design and automation. From engineering perspective, system must be properly sized and humidifier strategically placed to meet actual process needed. By integrating with a building management system, humidity can be monitored and adjusted automatically in real time. So finally, operational excellence is achieved through low maintenance design and regular sensor calibration, ensuring consistent and reliable performance. So for the next part, I will explain the key challenge in humidification system. So first, high energy demand is a major issue as electric and steam humidifier consume a lot of power, increasing operating costs. So next, hygiene and maintenance are important concern. Poor maintenance can cause microbial growth, mineral buildup, and affect air quality. So water quality is another challenge. High or untreated water can lead to scaly and unwanted impurity in the system. So in addition, changing environmental conditions such as the temperature and ventilation make it difficult to maintain consistent humidity level. So lastly, high upfront costs can be a barrier, especially since advanced humidification technology requires significant initial investment. So these all challenges highlight we needed for efficient, well-maintained, and cost-effective humidification solution. So in the conclusion, to keep industrial process running smoothly, factors like energy use, hygiene, cost, and environmental change must be controlled. By choosing the right humidification technology, improving automation, and ensuring proper maintenance, so operation can stay stable and efficient.